This is a demo of VC3, Virtual Clusters for Community Computation. This is a DOE-funded research project that will enable the creation of virtual clusters with custom middleware on top of existing national computing resources. This project is worked on by a team of researchers from the University of Notre Dame, the University of Chicago, and Brookhaven National Lab. And thank you to everybody who's contributed to this so far. Let's get started. First, to use the system, you log in, and we are hooked up to Globus authentication. So you simply use Globus auth to connect your existing university account, so you don't have to create a new password. You can simply use your existing campus credentials. Now, the system will show all the resources that it's capable of working with. At our current stage of development, we have 5 resources here, including the Cori machine at NERSC, 2 clusters at the University of Chicago, and Stampede, which is part of the NSF Exceed facility. Now, for each of those resources that I want to use, I need to connect my account and allocation. So I'm just going to go in here and enter in my account information for NERSC and also for Midway. And you'll see my accounts here or my allocations are listed. And what happens is in the background we'll generate a unique SSH key for that connection. And if you go in here and click on this, you can see the SSH key, copy that out. And you do have to SSH over to that cluster and install it so that the VC3 facility will be able to connect and submit jobs. Now I've already done that, so I won't show that in this demo. Now once we've connected up allocations, we're going to define some templates for clusters that we would like to create. And we're going to support several middlewares. At the moment we support htCondor and WorkQ. So I'm going to create a template for an htCondor cluster. So I pick htCondor here, and we'll keep the demo simple with 10 nodes. I'm also going to define a cluster template for the WorkQ middleware, which is going to allow us to run highly concurrent applications and workflows. So there are my cluster templates. Now before I make any clusters, I have to make a project, and a project is a container that allows me to collaborate with other people. So I'm going to add myself to add to this new project. And then if I go in and look in at the details of the project, I can see multiple users and maybe add a friend that I would like to collaborate with. And I also need to connect up the allocations that were created before. Right, so now that I have created a project, I am ready to create my first virtual cluster. So let me give it an arbitrary name here. And I'm going to pick my middleware that I'm going to use. For this first example, I'm going to use WorkQ, and I'm going to deploy it on the Midway cluster. So let's go ahead and launch that cluster. Now, as soon as I create it, it'll be in the new state here. And it does take a while for these clusters to get going, because there's a lot of work to do in the background. We have to stand up some infrastructure for the head node. We have to go out and connect to the remote resource and start running some jobs, and the jobs have to deploy the middleware and then report back home. So it does take a little while. There's a neat dashboard back here that shows you virtual clusters that have been created over the last 24 hours or so. And it shows the total number of cores at the different sites here. So you can see Midway, CoreOS, and NERSC have been used in the last day or so. And it also breaks them down by the virtual cluster that was created. So this is the same total number, but the colors represent individual virtual clusters, and you can also view the same thing by individual users as well. Now, one thing you have to remember is when we're going out and using these other computing resources, we don't control the scheduling. And so there could be a lot of people running or not so many people running on those individual resources. And it's possible we may have to wait in a queue. This graph over here shows the current queue state, so you can get a sense of whether you're waiting in line behind someone else at that resource. So I'll come back to the virtual cluster here, and we can see that it's pending, which means it's starting to be set up. And after about another minute or so, it'll get going. Okay, our virtual cluster is running and ready to go. And so this represents, this contains the WorkQ middleware running on top of the Midway cluster and reporting back to our head node. So let's SSH to the virtual cluster head node. And the example that we're going to run is a workflow. So we're going to use the MakeFlow workflow engine, and we're going to run a workflow called BWA. It's a Burroughs-Wheeler alignment. It's a bioinformatics workload. We're going to run it using the work queue middleware, and then we have to give the name of the virtual cluster so it knows how to run a view. Here we go. So the first thing that happens is the work queue locally indexes the FASTA data, and that it constructs 10 jobs to run, and each one of them is going to query a different part of the data. And each of those is going to communicate with a work queue worker currently running on the Midway cluster. And as those jobs get dispatched and then completed, we'll see them reported here in the console. So there we go, our jobs are completed and we're all done. So you can see that we use the head node to run our own middleware. Now let's go back to our virtual cluster, and we can tear it down anytime we want. So let me click on it and terminate it, and you'll see that it's flagged as terminating. And just as with starting up, terminating takes some time because we have to remove jobs from the remote cluster, and we need to tear down the resources at the front end. But eventually that will be marked as terminated. Now let me make some more virtual clusters. This time, let's make a HT Condor virtual cluster running on the Cori machine at NERSC. And we can make more than one virtual cluster at once. So this time let's do HT Condor running on Midway. And we'll get both of those going simultaneously. And you can see that, as before, it takes a little while for those to get going. Okay, one of our virtual clusters is ready to go. So let's go try it out. Again, we're going to SSH into the head node, all set up there. And I deployed a Condor virtual cluster. So now if I do a Condor status, I will see all the machines that have been allocated to me, reporting back to my own personal Condor pool. Now I'm going to run a different workload this time. What we're going to do is run Monte Carlo jobs for the Xenon 1-ton experiment. And what this is going to do, this script sets up a workflow using Pegasus, and then Pegasus submits it to my personal Condor pool, and then the jobs are going to run on the Midway cluster. And they're also going to make use of the CBMFS file system, which is deployed on the fly to deliver the software. And now I can observe the status of the job using a standard Pegasus command shown right here. So it shows me that we're just starting with one job, and if we watch this for a while, as the initial job downloads data and gets things ready, then we'll start to see more jobs running. And so there, we have jobs submitted to Condor. Some of them are already running, some of them are idle. Just a little bit longer, and we'll start to see more of them run. All right, so that's an example of running a real production application on Pegasus using Condor on a virtual cluster deployed on Midway by the VC3 service. So that's an introduction to the VC3 project. We're still in a development phase, but we hope to open the system soon to beta testers and other collaborators. I want to thank everybody who's worked on the project so far: Kenny Hurtado, Jose Caballero, Ben Tovar, Lincoln Bryant, Jeremy Van, Sushandra Thapa, Benedict Riedel. And the PIs on this project are John Hover from Brookhaven National Lab, Rob Gardner from the University of Chicago, and I'm Douglas Thane from the University of Notre Dame. Thanks very much.